Good afternoon, everybody. Thanks very much for attending our presentation today. So this is wastewater heat recovery for residential new build and how wastewater heat recovery can impact Part L 2021. So just a brief introduction into wastewater heat recovery, a look at how it works, an overview of the main products and a little bit of detail there on the individual products themselves. And then a look at why wastewater heat recovery is important for Part L and potentially for future home standard going forwards. And then a section on designing in wastewater heat recovery and the impact it can have on Part L. And then finally, some time for a look at case studies, and certainly a case study here with net zero and beyond, and then some time for Q&A. We'll just say we'll stop at strategic points in the presentation here just to see if there are any questions from the floor, but if not, we move on. So who uses wastewater heat recovery? Well, at the moment in the UK, it's mainly used by new build housing developers to achieve Part L compliance. And with the advent of new regs, there's a much bigger interest in wastewater heat recovery, and that's certainly something we'll come on to as we go through the presentation. Wastewater heat recovery is ideal for new build housing with showers on first floor and above, but we've also got products suitable for apartments, bungalows, passive house, etc. And then also with the advent of Part L for non-residential environments, we've seen a much bigger uplift interest in wastewater heat recovery for instance, student hotel accommodation projects, as well as anywhere where there's high shower traffic use, so leisure and sports facilities, where there's typically very high shower use can benefit very much from wastewater heat recovery. And then looking towards the future, we expect to see a much bigger uptake as for retrofit as existing homes look to decarbonise. The low-hanging fruit of space heating and fabric is taken up, and then more focus on hot water and certainly water for showering. So that's the main uses so far. And then the question of why use? Well, wastewater heat recovery can offer significant energy and CO2 reductions, especially for new build. It's very easy to incorporate into new build with very little layout adaptations required. It takes up a very small amount of room, and we'll kind of show that as we go through. But also it's very simple, cost-effective Part L compliance, so it gives a good uplift in SAP, as we'll see towards the end of the presentation, and certainly one of the cheapest and most cost-effective measures to gain SAP points. But as well as the compliance tick box, there's also significant hot water cost reduction for end users. So our vertical pipe system installed into a standard new build can reduce the energy required per shower use by up to 55%. So it really is quite significant. So less hot water used for showering and or less energy required to produce that hot water. And we'll kind of look at how that works out in a moment. And very importantly, there's no end user interaction required with wastewater heat recovery. It's a passive heat exchanger technology, instantaneous. So whenever the shower's switched on, it works. Can't be switched off. There's no isolator switches. If it, other technologies where they might rattle or filters get blocked, it doesn't have that. It's just part of the plumbing infrastructure and always works every time the shower's switched on. So a few of the other benefits, as I said, it's very easy to design in, very simple compared to most other SAP measures, and relatively cheap to install. It's a fit and forget passive measure with no end user interaction required. Has a very long working lifespan. It can really be considered in line with the plumbing infrastructure, certainly 40 to 60 years of a serviceable lifetime. And it also has a very low embodied carbon, certainly compared to the amount of energy it can save per year. So we'll look at that towards the end as well. But if sort of direction of travel with regulation is embodied carbon is going to become a much bigger part. So we'll take a look at that as well. So just to, excuse me a moment. Just to have a quick look at some of the products in detail. So we have a portfolio of products, but the main products that are used for house building are the vertical pipe systems and then the horizontal systems such as the Easyfit. So we'll just take a look at those. Just as a quick reminder to those that have come in late, if you can click the fit to frame on your Teams browser there, that should make sure that everything is kept in frame for you. So just a quick video to look at how wastewater heat recovery works. So this is based on the vertical pipe system designed into a standard house type with a first floor shower. So normally when you shower, your hot water coming out of the shower head is really a mix of around about 50% generated hot water at about 60 degrees and incoming cold water main at about 50 degrees, about 10 degrees. So a 50-50 mix, and that mix is controlled by the thermostatic mixer. So wastewater heat recovery to be SAP compliant requires a thermostatic mixer shower, but that's pretty much the only prerequisite that is required. So your 50-50 mix of hot and cold, of that, around about of the sort of comfortable 40 degrees coming out the shower head, around about 85 to 90% of that heat energy, it normally goes down the drain and is lost out of the building. So there's a big waste with showering in terms of hot water. So with wastewater heat recovery, we attach essentially a heat exchanger to the outgoing warm shower waste, and we use that warm shower waste to preheat the incoming cold water main. So where your incoming cold water main temperature would normally be at 10 degrees, we can preheat that up to around about 25 to 28 degrees. So it really is a big free issue temperature uplift. And that's the same basic premise for all wastewater heat recovery. It's warm waste out, cold water comes in and is preheated. But from there, and I'll move the slide on if that's okay, from there are three recognised installation methods in SAP called System A, System B and System C, and they're simply concerned with where the preheat is piped to. So with System A, which is the most efficient and normally used on a primary shower in any new build, System A sends the preheated water to the cold side of the shower mixer. So now your thermostatic shower mixer will automatically detect that preheated water is coming in, and it will automatically adjust the ratio of hot to cold in favour of more free issue cold side water. So it will move the ratio from about 50-50 to about 75-25. So immediately you're using less hot water per shower. But also, as you can see here, we're teeing off and sending that preheat back to the hot water source. So in this case, we're showing a hot water cylinder, but from the point of view of wastewater heat recovery, we're technology agnostic. So that could be a heat interface unit, a thermal store, air source heat pump, combi boiler. It really doesn't matter as long as there's a thermostatic mixer shower there. So by sending the preheat back to the hot water source, instead of that hot water source having to raise from 10 degrees up to 60, it's now raising, for instance, to 25 to 60. So the boiler has to do less work to produce hot water, and on the other side, you're using less hot water per shower. And that really is the basic premise of wastewater heat recovery in its most efficient. Then we have System B, where quite simply we send the preheated water to the cold side of the shower only. So by sending, as I said, to the cold side of the shower, we use less hot water per shower. This is the least efficient method of installation, but it's still significant. This will reduce a sort of 11 litre per minute shower in a standard house type by about 42 to 43% of the hot water used per shower. So it's really still quite significant. This tends to be used for any secondary showers in a dwelling, or perhaps where the hot water source and the showers are on different sides of the room, and to keep the pipework a little bit less. And then also, just for completeness, System C, as you may well have guessed, sends the preheat just to the hot water source only. Not used too commonly in residential, except maybe where you've got a townhouse arrangement. So if you can imagine you've got stacked showers on the second and first floor, it's probably a lot easier to install a pipe on the ground floor and just pipe that preheat to the cylinder, which may well be in a ground floor utility or something along those lines. So that's the basics of wastewater heat recovery. Just to try and put that into some kind of context in terms of energy savings, as I mentioned earlier, around about 55% in the standard house type. So this is looking at the pipe installed as System A at both 11 litres per minute and 9 litre per minute shower flow rates. And as you can see, as the shower flow rate drops, the efficiency of the system increases, and so therefore the relative energy demand also decreases. So it really is quite significant there. Anyway, sort of 55 up to 60% would be expected in most installations. And then as a system B option, I mentioned this was the lower efficiency method of installation. We're still looking around about 40 to 43% of hot water demand reduction. So again, really quite significant. I'll just hold there. James, any questions that I need to be aware of? Any questions from the floor?
Nothing coming so far.
Okay, great. I'll move on. So just to focus on those product types. So we tend to focus on the vertical pipe systems because they are the most specified and certainly most used for new build housing, and this being a residential new build presentation, it's the most appropriate product. It's a 2 meter vertical pipe system, so literally a 2.1 meter vertical heat exchanger unit, installed height of around about 2.35 meters. And as you can see from the graphic here, it tends to install directly below the shower or within about 3 meters of the shower, and normally boxed in next to the SVP. So it takes up very little space, and normally the homeowner wouldn't even know it's there. It's just a slightly bigger boxing, as I'll show you in a moment. Very simple first fix installation. Installed at first fix, really warm waste going in, as you can see here, going into the turbo rotator. The turbo rotator at the top is simply there just to direct the flow of wastewater so that it clings to the inside of the heat recovery pipe. So it's clinging to the inside of the copper pipe. And then as you can see here, on the blue at the bottom, cold water main goes in the bottom, goes around the outside of the unit and is preheated. So warm waste going in at about 34 to 36 degrees, vents off at about 18 degrees. Cold water main comes in at 10, comes out about 25 to 28. And then in addition to what we supply as a unit with the installation kit and the pipe, all that's simply needed is 2 isolation valves and a double check valve, and that's it. It's SAP compliant. So very simple installation. I mentioned the turbo rotator at the top there. This is a new waste connection that we've had on for a couple of years now. It ekes a little bit more out in terms of efficiency, but also gives a slightly lower installation height, which means that these systems can install into quite comfortably into standard 2.4 meter ceiling heights. But even if you've got a slightly lower height, the waste part can normally drop into the ceiling void, so it will be taken away in the ceiling void. And in terms of efficiency, the lower the specified shower rate, so if you've got a shower flow rate of around about 8 litres per minute, for example, or 5 litres per minute, you're going to get a slightly better heat recovery efficiency because the flow through the unit is slowed down, the volume of water is less, so it picks up more heat as it goes through. As I mentioned, very little design changes, so if you've got current house types that you're looking to upgrade for 2021 regs, realistically adding wastewater heat recovery really takes up very little extra floor footprint. So as you can see, a standard SVP boxing might be sort of 220 by 220 with wastewater heat recovery installed within that boxing. It's really adding around about 200 mil in one direction, so very little extra floor space taken up. And then it's also worth mentioning here that all of our wastewater heat recovery units use a double-walled heat exchanger system. It means that we're directly compliant with UK water regulations. It means that the shower trap can stay in place underneath the shower where it should be. And it essentially gives us a visible leak detection system. So if at first fix there was ever a perforation between the heat exchanger and the potable water, there would be a visible leak from the unit, and then that unit would be exchanged out. It's also worth mentioning at this point, in practice, in 10 years of selling into the UK market, that has never happened. All of the products are pressure tested to 6 bar before they leave the factory gate. So there's essentially almost zero possibility of a perforation in the unit, but it's there as a belts and braces approach, and it means that we can directly comply with water regulations. And then finally, just for the developers in the room, we are the only product that's stocked and sold by all of the national merchants, so we can directly dovetail into existing supply chains, contract supported pricing, framework agreements, etc., etc. Sorry, just very quickly, just installation operation. As I mentioned, it's a first fix installed product in a new build house. Depending on the installation method, we normally anticipate 1 to 2 hours extra plumber's time. Only basic plumbing tools, knowledge, materials are required. There's no MCS accreditation, for instance, no specialist certification or tools required, and no specialist commissioning either at the end, just standard pressure testing, and the unit's ready to go. No planned maintenance either. There's no mechanical, electrical or moving parts in the wastewater heat recovery unit. It's a heat exchanger pipe with no moving parts, no filters, no consumables. So for all intents and purposes, no planned maintenance. It can be boxed in. It's a fit and forget product. And then also, as I mentioned earlier, no behavioural changes. So your end user, your homeowner simply won't know it's there in most cases. And so it really is a very neat solution to Part L compliance and energy efficiency. So the vertical pipe system really is the best product for new build housing, but obviously it does, because it's gravity fed, it does require to be located on the floor below the shower it's attached to. So great for first floor showers and above, but where we don't have those, we then have other options in terms of horizontal wastewater heat recovery systems and pump systems. So the Easyfit is our underbath system. It's a fantastic horizontal unit, which is, as you can see, designed to fit directly into the unused void space under a bath. So doesn't take up any additional floor space at all, locates directly under the bath and connect to the thermostatic mixer shower above. So yeah, very, very useful in terms of additional compliance, or perhaps if you get into a point where Part L compliance hasn't been met for any reason, this can be a late stage addition to gain compliance in a lot of cases. By nature of its design, it's not quite as efficient as the pipe system. So where the pipe is around about 65% heat recovery efficiency, depending on flow rate, this is around about 43 to 47%. However, it still scores very well in SAP, and certainly in apartments, by the nature of the way that SAP's calculated in apartments, it can score equally as well as the vertical pipe system does in houses. So it really is, again, quite significant and a big bang for your buck, essentially, in terms of SAP score. Ideal for apartments, for ground floor showers, but also can be used to fit under a suitably sized shower riser tray. Normally anything sort of 1300 mil long and above. So a relatively large tray, but certainly on modern apartments, that's not normally a problem. And it works in the same basic principle. Warm shower waste goes in on the yellow there, goes through the unit, so it's allowed to fall into the pan and flow through, and then vents off to the SVP as it does with the pipe. On the same token, the cold water main comes in on the other side. In this case, goes through a serpentine heat exchanger and comes out preheated. The exchanger is designed in such a way that the wastewater is allowed to flow over and mix, but also flow under. There's about 2 millimeters above the pan from the exchanger, which allows any debris that may come through from the trap to just flow straight through the unit. So there's no compressing of the wastewater flow in this unit. It's allowed to flow through, and therefore we're not causing bottlenecks or anything. So there's no risk of clogging or blocking on these units. But I will say, I mean, they're also used with RAS certified materials, copper, ABS plastic, PVC, and they can be flushed through with standard drain cleaners. They're big enough to have a plumber's brush go through, etc., etc. So standard shower maintenance is certainly applicable for wastewater heat recovery units. As I mentioned, great SAP score in apartments, and certainly a very beneficial SAP score in houses as well. So the Easyfit's great for showers over under baths, but obviously with the trend of smaller showers in some flatted developments or flat trays, so non-riser trays, low profile trays, the Easyfit isn't always an option there, and maybe the pipe isn't the option. So we've just about to release a pumped upgrade kit to the existing pipe. So the idea here is that we can pump up and over, so it's an active pump up and over rather than gravity feed, and that allows the pipe to be installed on the same floor as the shower it's connected to. So as you can see here from the graphic. So it has a lot of benefit for apartments. Normally, the primary shower in many apartments is a shower over bath, but there is a trend now for showers only in apartments, or also where maybe you've got ground floor showers with DDA accessible showers, etc. Then this is a good option. So very flexible design. The pump is a Saniflow unit, so we've partnered up with Saniflow here. It's a great product with a good pedigree and good servicing and maintenance history. So it gives a great flexibility in terms of designing in. Obviously the wastewater heat recovery unit itself is essentially planned maintenance free, but the pump system does need to be installed in an area where it can be accessible for future maintenance. So the flexibility in the design is such that the pumped unit can be around about 1 to about 1.5 meters away from the pipe. So maybe installed underneath a vanity unit or something along those lines. So it really does give good flexibility. And this is coming into the market this month, it should be, or sorry, this end of this month, and be SAP listed this month as well, so be available very shortly. And then finally, just for completeness, we do also have a range of wastewater heat recovery integrated wet room drains. These units tend to be used more for non-residential, so communal changing rooms, etc. But a very neat solution again, wastewater heat recovery elements all enclosed within the drain housing itself, everything accessible, and again planned maintenance free. So it's a really neat solution for commercial and communal showering environments. A more expensive system, but with fantastic efficiency. Sorry, I seem to be going through that slide twice there. Let's go for that. That's as deep as I'm going to get on the products here at the moment. I mean, if there are any questions, or if you want any further information, we can talk offline or separately. But again, James, just see if there are any sort of pertinent questions at this point.
Yeah, thanks. So, we had a question in from Andrew Bolton. You did sort of mention it briefly in your earlier slides, but he was just wondering about low flow rate showers, in particular 6 litre showers.
Yes, so from our point of view, the flow rate, we do specify 5 litres per minute as the lowest flow rate. However, that's the lowest flow rate that we test to. In reality, low flow rates really don't impact, but at 5 litres per minute, perfectly fine. The case study I'll come on to at the end shows a net zero ready house which uses ultra low flow rate showers, and the wastewater heat recovery is designed in there and working perfectly fine. So yeah, low flow rates really shouldn't be an issue, but obviously the positive there is higher efficiencies and potentially more energy saved per in terms of percentage savings. So why is wastewater heat recovery important? So obviously regulations, but regulations are moving towards much more energy efficient homes and more insulated and more thermally efficient in terms of space and air tightness. And what that tends to mean is that the hot water use, which realistically homeowners don't necessarily change their hot water use or their showering habits just because they live, for instance, in a passive house, tends to, by comparison, become a much bigger part of the energy budget. And so hot water going forward is expected to be the biggest energy user in homes. And as we can see here, showering is the biggest part of that hot water generation. So showering in a standard house or standard home would normally be expected to take around 50% of generated hot water use, but in apartments that can easily be up to sort of 70, 80%, even more, because just by the fact that most other devices that use hot water, dishwashers, washing machines, etc., produce hot water internally rather than from the generated hot water system. So showering really is a big part of that generated hot water energy use. And as I mentioned earlier, about 85 to 90% of the heat energy from the shower normally goes down the drain, leaves the building. It's the equivalent to leaving a window open realistically every time you shower. And it's certainly something that no sane person would do. So when we look at this in terms of percentages on the average UK home, space heating would normally be around about 2/3 of the energy use, hot water sort of 18 to 23%, If showering is 50% of that and 85 to 90% is going down the drain, that's potentially about 10% of that home's heating and hot water budget going down the drain and leaving the building. So it's a big energy loss. When we look at this in terms of the expected energy budget for current Part L regulation homes, space heating is much more reduced, but by comparison, hot water as a percentage is increased, and therefore the amount of energy wasted and going down the drain without wastewater heat recovery is increased. So it really is a much more important thing going forwards. And fortunately, the regulations do seem to be taking account of that. So when we look to, I'll just gloss over Future Homes 2025 because consultation is due out towards the end of spring next year. So we're not a complete understanding of what's going to be in Future Homes 2025, but at the moment the expectation is all electric heating and hot water systems, a ban on gas boilers, a 75% lower CO2 from current standard. But the main takeaway from it is that, or the main driver with it is, the idea is that from 2025 we'll be building new build homes that will decarbonise and go to net zero as the grid decarbonises without the need for future retrofits. So that's the idea is to reduce energy demand and electrify as much as possible, and wastewater heat recovery sits in that in terms of its ethos of demand reduction. But in the meantime, we have the Part L 2021 interim regulations, so the stepping stone regulations, if you like, which come into force in June 2021, so this year, with a 1-year transition, and will be every new build home in England will need to be built to Part L 2021 from June next year. And I think I'm right in saying the regulations for WOWs have come into force today. I think also with a 1-year transition, and Scotland's yet to announce, but they will be following shortly. So going forwards, the direction of travel is obviously energy reduction going forwards, and Part L is pushing that forwards. So yes, so sorry, jump forwards a little bit there, but yeah, so regulations went live, and transition is 1 year, so a relatively short transition. The regulations as they stand now are the first regulations which have included wastewater heat recovery in the notional dwelling, which is why currently there's a big focus on wastewater heat recovery, and quite rightly so, but certainly it's the first time that regulations have included wastewater heat recovery, and certainly in terms of what we're seeing from standard house types with gas boilers on sort of the larger volume developers, it's very difficult to see a solution to go forwards which doesn't really include wastewater heat recovery. So certainly the stat modelling seems to bear out the notional dwelling here. So going forwards, key changes, gas boilers still permitted on 2021 regs, and the expectation is that about 80 to 90% of new builds will include gas boilers. Obviously, heat pumps are there and are expected to become a much bigger part of new build homes going forwards, but at the moment there isn't realistically the infrastructure for all new build homes to use air source heat pumps, and also not the installation infrastructure either. So it's certainly a direction of travel rather than the expectation at the moment. And so the expected prescription for new build Part L compliance currently is increased fabric, wastewater heat recovery, gas boiler and PV. So that seems to be looking as the most cost-effective solution. So that's kind of where we're seeing that, and certainly with the volume developers that we're working with and supporting, that tends to be the prescription that they're working to. So the reason, so secondary benefits for wastewater heat recovery, I guess, it allows the use of known and available technologies. So developers are comfortable with gas boilers, with PV, with fabric upgrades. And certainly there's lots of other third-party research looking at how wastewater heat recovery tends to work very well with upgrading homes to meet new Part L. So this is a slide from Future Homes Hub, which has got some fantastic information out there, some really good guides. So this is just a quick slide showing the various suggested routes to upgrade from various cavities, so maybe 100 mil cavity, which might be a standard for 2013 regs, 2021 notional dwelling fabric, and also for future homes anticipated fabric. But what the suggestion here is that wastewater heat recovery really should be used across the board for that energy demand reduction, and certainly for future-proofing homes going forwards. Again, easier transition, infrastructure transition if we remain with gas for the interim regs. And wastewater heat recovery is a fully scalable technology, very little training required, and certainly a product that can be scaled to meet demand going forwards. I'll just take a moment there, just see if there's any, sorry, it's a bit of a whistle-stop tour, that one, but just see if there's any questions there.
Yes, there was a question coming from Derek. He is asking about payback ROIs in some typical domestic installations. I know you're going to go on later in that, so
yeah,
I don't know if we'll leave it to them.
Yeah, it's okay. Yeah, I've got a slide towards the end of this section actually, which shows some ROI for standard. I mean, it's probably worth mentioning for new build housing, as a developer, the end user ROI isn't necessarily the driver for this. It's really, I need to get Part L compliance and need to do it in the most cost effective way. So I guess the ROI maybe for the end user is that they're not paying for more expensive technology that's needed to get that Part L compliance. But for individual projects, for a deeper dive into sort of new build SAPs and for retrofit, we can produce calculations which are very granular, either using SAP defaults or user data to give ROI. So I'll kind of give an example of that in a moment. I think, well, coming on to that really, I mean, designing in wastewater heat recovery is a relatively simple technology, and really doesn't take a great deal, especially compared to a lot of other technologies to design in. In most cases, for most standard new build homes with maybe 2, 3, 4 bedrooms, 1, 2 bathrooms, one wastewater heat recovery pipe installed to the master or the primary shower as system A is going to give the biggest uplift in SAP, and certainly probably the biggest cost efficiency benefit in SAP as well. So that realistically, whilst there are always going to be outliers in terms of design and big self builds, etc., for most new build designs, a single pipe installed as system A is really going to give you the biggest uplift. So if there's any takeaway from this, I think it's probably that, as well as if you've got anything that's outside of that, feel free to lean on us. We have a full technical team here. We're happy to go through floor plans and advise on wastewater heat recovery options for you. And I'll come on to an example of that now. But really 2, 3, 4 bed homes, single pipe really is the biggest impact from a pipe as system A. Larger house types may require more wastewater heat recovery, but if you are a specifier, architect, SAP assessor, and you have some influence over the design and the layout, I'd really stress if you can consider wastewater heat recovery early on, perhaps put your bathrooms back to back, then it's quite possible that where there are more showers or an ensuite shower over bath, for example, as shown here, a single pipe can potentially then be used, and it keeps that cost down. Although the costs aren't great, any cost saving is a benefit. So maximising the coverage of the wastewater heat recovery, but minimising the cost. So again, we're here to support you with that, and feel free just to send your designs, floor plans, etc. over to us. Engage as early as possible. That's what we're here for. So just a typical sort of designing journey then. So if we were sent some house types through group or something along those lines, or for a development, we can go through them and make some suggestions. So here what we're looking at is just a modelling example just to show the impact in SAP. So we're looking at a 3 bed, 2 bathroom, shower in the primary ensuite with just a bath in the family bathroom here, so on the example. And so what we would normally look at, as I said, is the wastewater heat recovery unit. So the pipe installed as system A to the master ensuite. The pipe's going to locate on the floor below the shower it connects to, so boxed in next to the SVP. So if we were sent floor plans like that, we can return a spreadsheet with various options. Obviously this is a relatively simple one here, but what we'll always come back with is that list of options from biggest impact down to lowest cost. but also with specification notes. So as a specifier, you understand what we're specifying and why, but also can attach those notes to the drawings so that they follow the design all the way through, which is certainly useful for bigger group drawings or larger projects. But also we can attach with design and installation notes as well. So notes for the installers further down the line, so they know with some clarity as to, again, what's been specified, why, which shower to attach to, etc., etc. Because obviously this is a SAP modeled technology, and any deviation from that in terms of installation versus SAP is going to generate a performance gap and potentially compromise your SAP compliance. So it's very important to make sure that the as built is the same as the as designed, and so we try and help with that as much as possible. And also for the SAP assessors in the room, we'll always attach the PCDB numbers, so you can just plug those into the SAP modelling software and they will just populate for you, which I will show you an example of here. So hopefully there are some SAP modelers in the room. The SAP 10 journey sounds like it's been a bit problematic for a lot of people, but finally it does sound like it's almost completely working. But certainly with regards to wastewater heat recovery, SAP modelling seems to be working quite well now. It's relatively simple to design wastewater heat recovery in. It comes in as you'd expect underneath the hot water tab, and we're shown here 28. Simply enter a checkbox that wastewater heat recovery is going to be included. And then from there, you can select the wastewater heat recovery system, or as I said, you can drop in that PCDB ID number and that will self-populate. Need to just account for how many baths and showers are present. And then this is the bit that we've found that a lot of SAP assessors are missing. They're putting in the details, but not attaching the wastewater heat recovery unit to the shower. So it's very important to hit the plus button, sometimes at the top of the screen here, sometimes down below, depending on your screen, which is why I think it's missed sometimes because it's dynamic in SAP. But yeah, if you click the button and then you can, pops up the screen here and you can enter the wastewater heat recovery, which wastewater heat recovery units are being attached to which showers. So you can specify the shower flow rate, so that will obviously affect the efficiencies. And obviously, again, if you've got low flow rate showers, you can specify that and you'll get that additional boost from having low flow rate showers in SAP as well. And don't forget to connect using the tick box here. And it's as simple as that. And then in terms of the impact, wastewater heat recovery, it really is very impactful in SAP. It's offering significant SAP savings. So as well as the CO2 metric, there's now the primary energy metric as well in SAP. So we're showing both here. So that 3-bedroom mid-terrace that we sort of just showed the example of with an ensuite shower and a bath. If we look at the modelling there, as you can see, hopefully, sorry, it's a bit of a small slide. On this particular instance, we're showing a primary energy reduction of around 10.7% and a CO2 reduction of 11.10%. So that really is quite impactful and certainly would generate a good SAP score, a good SAP uplift. This is based on the sort of the notional dwelling standard for that 3-bed home. So we were asked about the ROI. As I said, we don't normally need to do this level of granularity for developers because it really is that SAP compliance is what's being looked for. But if you do want to delve into it a little bit more, if you are looking at projects with ROI or where kilowatts, for instance, SBEM, DSM modeling, where kilowatts are important, we can go as granular as you need to. So this is an example using the SAP defaults for the example we've just shown there. And as you can see, we've got an energy reduction of 1.7 kilowatts per day. I'm sorry, I can't quite see myself here. That's coming about, I think that's 628 kilowatts per year. So really big energy numbers. And in this example, with the pipe installed as system A to a 9 litre per minute shower, we're looking at 58.4% energy demand reduction for showering. So really quite significant. What I will draw your attention to here is the CO2 savings per year. So we're showing here on gas at the top, on LPG, on direct electric, and then air source heat pump. I'll just ask you to bear those in mind. In fact, I'll go onto the slide in a moment, because when we look at the embodied carbon contained within our wastewater heat recovery units, so this is the embodied carbon calculated through TM65, which is the CIBSE standard for calculating embodied carbon for the vertical pipe system, you'll just see at the bottom of the unit there, I'll skip through this because we're running a bit low on time, that we have an embodied carbon number that's incredibly low, looking at around about 59 kilograms of CO2, embodied CO2 per product. And that's a factor of the fact that we use a circular manufacturing methodology, but also the majority of the components are either recycled, recyclable, and in the main by bulk is copper, so it's a highly recyclable material. So when you compare that embodied carbon value with the amount of CO2 the unit can save per year, it really shows how insignificant or very small that embodied carbon is in the units. And certainly when you compare to a lot of other technologies in Part L, it really is very, very low in terms of embodied carbon. Something that a lot of developers have got their eye on, if not now, then for the future. And certainly SAP 11 is expected to have an embodied carbon element in it. Focus mainly on housing there, but obviously wastewater heat recovery can be used in apartments as well. So just very briefly here, if we were looking at a standard apartment floor plan where maybe you've got a shower over bath as your main shower, and then perhaps plus or minus an ensuite shower, the obvious choice and certainly probably the most cost-effective choice for most apartments is the Easyfit under the bath installed as System A. So normally that was going to give you the most cost-effective solution. However, if you do also have ensuite showers, which are showers only, the Easyfit may well work as an under tray shower, as I mentioned before, but this is where the Pipe Hex Active comes into its own. Can be designed to locate in the service void behind the shower, doesn't fall down into the flats below. Everything's contained within either the dwelling or potentially within the bathroom pod. So it really is a very neat solution in that respect. I'll just hold that there. Just very briefly, just onto a case study. Any number of case studies for standard new build housing, and certainly for Part L going forwards now, we're seeing use to meet current regs. And there's plenty of case studies on our website, so I'll draw you there if you want to have a look at case studies. But this one in particular is, we've been fortunate enough to be sole supplier to BARRATT for nearly 10 years now. So we've got a great sort of partnership arrangement or relationship with BARRATT. And as such, they are looking to use wastewater heat recovery going forwards. This is their Z House, which is a exemplar project which are put together using an existing 3-bedroom house design, which is capable of being net zero now. And it uses around about 40 different energy efficiency and sustainability and ecologically biased technologies which are available in the market now. So cutting edge technology used to on an existing floor plan, an existing house type to really show what the 2030 and beyond could look like. And as such, they've included wastewater heat recovery in here. So the pipe hex here is installed to the shower above, so the ensuite shower, which includes a Kelder low flow rate shower. So it's an 8 litre per minute powered shower, and works very well with there. And then also connected to the shower over bath, which has a more traditional flow restricted 8 litre per minute shower. So the wastewater heat recovery working very well, playing very happily with the other technologies there. And then just to sort of emphasize the fact that it takes up so little room in this site. So certainly something that we hope is going to be considered by most developers going forwards in terms of energy demand reduction to maintain that. Sorry, I'm just very conscious of the time. We're going to just very quickly, we have an awful lot of resource available on the website. We have a dedicated learning site, YouTube videos, installation videos. We have obviously CPD presentations online, either these live presentations or direct one-to-ones that you can download and go through at your leisure. And also we have a full studio here. So if you're a developer and you're looking for branded toolbox sessions, if you're a merchant, you want branded materials for wastewater heat recovery, we can help you out with those. So last thing to say thank you, and because we are an online lunchtime presentation, and Normally it would be a lunch and learn and would send you a sandwich or something. We've to try and maintain our sustainability route going forwards, we now operate a CPDs for Trees program. So I'll send you a link at the end of this so you can get your CPD certificate. But just to mention that every CPD certificate that we generate will donate 25 trees to through Ecology to help promote sustainability and kind of hopefully help people along on their sustainability journey. And if that's okay, I will hold that there and just see if there are any questions from the floor. Jane?
There's no further questions on the chat box. Obviously, yeah, open floor now if anyone wants to approach you direct and ask a question. Okay.
Good stuff, thank you. I mean, if anybody has any particular projects that they're looking at, if you want a sort of, we can always do one-to-one team calls and things, look over drawings with you. Yeah, that's really no problem. So if there aren't any questions, are there any questions? No, okay.
Sorry, this is Paul Gordon here from Arcades.
Hi, Paul.
One challenge that I'll find is when this item is specified and everyone wants it and appreciates it, we price it in and then it becomes the first BE item. I just wondered, what's your thoughts in terms of how we can protect this sort of technology and, as you said, a way of working going forward with this sort of system in place as a standard, as opposed to just a bolt-on which then gets removed?
Yeah, so it's certainly something that we've seen going forwards. I would think certainly on former regs, wastewater heat recovery has maybe been seen as a bit of a luxury bolt-on, and as you say, often it is the first thing looked to be VE'd out because the focus is on space heating, insulation, air tightness, etc. With new regs going forwards, and certainly for those under London Plan, it seems very difficult to get through without either excessively spending on fabric and facade without wastewater heat recovery, and obviously the thing as well, you can throw more and more money at facade and fabric, but there is a diminishing returns there. So a lot of it is a mindset change and look at and seeing wastewater heat recovery for what it is, and that is energy demand reduction on the hot water side. But in terms of keeping that spec in there, we can supply template documents which include specification notes, either with our products listed or without the products listed, so there's minimum efficiencies and various benchmarks that need to be met, so that we can't just be VE'd out without other wastewater heat recovery units that are inferior. But also in terms of the working with the supply chain, we can always look at putting contract supported pricing in place that links to particular projects to make sure that when this is sold through the merchants, that there's not margin on margin being put forward, or at least we can't stop margin on margin, but what we can do is make sure that the most cost effective pricing is in place for volume based projects. I think it's probably as good as we can do there at the moment. But the reality is it's as we go forward, it's going to be more and more difficult to get through on fabric measures only, I think, and certainly sort of the other bolt-ons such as PV and that sort of thing.
Brilliant, okay, because I'm trying to make sure that these costs are realised at stage 1, stage 2. I'm trying to put a detail in there, so when it comes to the stage 3 and when the contractors do get on board, it's embedded in the cost.
Yeah.
It's not shock to anyone. So
perhaps we could have a quick chat afterwards, or maybe a call sometime this week, Paul. I can just go through some of the specification documentation we've got and see if that helps. If not, we can work with you and try and find some way that we keep that in.
That'd be really handy, because then what would be your narrative and the cost? So it is to say a one-line item is a one-line item with the cost and the associated spec, so it has to be embedded.
Yeah.
Just remove that one-line item. That's really handy. Thank you.
As much as possible, we try to, if we can embed sort of links and education element in it, then even when you get to, you know, the quantities guys at the end, they can understand why this is in, and it isn't just a luxury bolt on. It's a requirement, you know, it's a necessary and where it impacts. So that's what we're trying to help.
Brilliant, great. Yeah, look forward to having a chat with you.
Thank you. Anybody else before we finish up then? Great stuff. Okay, well look, Thank you very much, everybody, for your attendance here. A copy of the presentation will be sent out, or rather, a link to the presentation will be sent out to you, as well as the CPD certificate link and a link with our the technical team's details as well. So please do feel free to come to us if you've got any projects or inquiries. And there I will sign off. So thanks very much, everybody. Thank you.